binomial probability function in Excel gives us a probability of finding some fairly complicated events. To use it, we need to have a situation where an experiment can be defined as having two possible outcomes. For convenience, we tend to call those two outcomes success or failure. And we need to know the theoretical probability of success in a single trial of the experiment. For example, flipping a coin, for each flip of a coin, the probability of heads is 0.5, and we can designate heads as being success and tails as being failure. If a customer walks into a store, we may know from historical data that the probability that a sale is made to a customer is 20%, and we can call the sale success. And the probability of not making a sale would have to be 80%, and we can call that failure. If we're spinning a roulette wheel and we put a bet on red, the probability of red is 18 out of 38 for each spin of the wheel, because there's 38 possible outcomes and 18 of the numbers are red. So the binomial function in Excel will find the probability of having X successes in N trials of an experiment. Again, for example, if we flip a coin 6 times, that'd be 6 trials of the experiment. What is the probability of observing exactly 4 heads? So heads we're calling success here. So getting 4 heads out of 6 trials. 3 customers walk into a store. What's the probability of making a sale to exactly 2 of them? So 2 successes in 3 trials. You bet on red for 10 spins in a roulette wheel. What's the likelihood you win at least 5 times? So let's look at some examples. In particular, you flip a coin 6 times. How likely are you to see exactly 4 heads? So the outcomes of this experiment are a binomial distribution because we have the 2 possible outcomes. And assuming the coin is fair, the probability that any one flip of the coin is a success is the same for each flip, 0.5. The possible outcomes of this experiment are 0, 1, 2, 3, 4, 5, or 6 heads, where that would be the number of successes, and we're specifically interested in observing 4 heads in our 6 trials. Now the format of the binomial function takes a little getting used to because there's 4 different parameters we've got to define. So the format, when you type in BinomDist, will pop up. Let's just go ahead and do that here real quick. Equal binom. And I'm using this version here, the BinomDist. And again, it pops up with some hints. Number underscore S for number of successes. The number of successes we wish to find the probability of. Trials is the number of times the experiment will be performed. Probability of success. And then the cumulative is the hardest one to explain. We'll do a couple examples of that. It's going to be either the word true or false. We use false if we want the probability of exactly N successes, so exactly 4 heads, or the probability of 4 or fewer, then we write the word true. So for example, in our 4 heads and 6 tosses of a coin, we're interested in the number of successes being 4. The number of trials is 6 because we're going to flip the coin 6 times. The probability in any one of those 6 tosses that we get heads is 1/2 or 0.5. And then we're going to use the word false because we want the probability of exactly 4 heads. And we'll get a number between 0 and 1 because all probabilities need to be between 0 and 1. So there's a 23% chance, approximately, of getting 4 heads in 6 tosses of a coin. And if you're interested, those are all the different ways we can get exactly 4 heads in 6 tosses of a coin. Now let's do a variation on this example. We're still tossing 6 coins, but this time we're going to find a whole probability distribution. So again, the possible outcomes, if we're flipping 6 coins, we could get as few as 0 heads, or we could get 1 head, 2, 3, 4, 5, up through 6 heads, all 6 coins coming up heads. So what we've listed here are all possible outcomes of an experiment where we toss 6 coins and count the number of heads. And what we're going to do then, the probability distribution will give us the probability of each one of those outcomes. So the probability of getting exactly 0 heads, I'll find with the binomial distribution. And We'll just use C4 here, and then we can copy our function down. 6 heads for the number of trials. 0.5 or 1/2 for the probability of getting a head in any one outcome of that trial. And then the word false, because we want the probability of exactly 0 heads, exactly 1 head, etc. And then if we copy this down, we get our whole probability distribution. When you're displaying this, sometimes I find it helpful to show more decimal places or fewer decimal places, just to make the table a little more consistent when I'm comparing. You'll notice that 3 has the highest probability, which makes sense. If you toss 6 coins, our most likely probability is that exactly half of them would come up heads. And the probability of either 2 heads or 4 heads are a little less likely, but still high up there. And then let's see, I wanted to come over here and show you, talk a little bit about the cumulative, the true-false part of our function. So I'm going to do a second row here, binomial distribution, 0 heads. There we go. Trials is still 6, probability still 0.5, and I'm going to write the word true here. And I get the exact same outcome for the probability of 0 heads. And then this second column here, what I'm getting is a running total. Right here, the 0.109, this is the probability of getting 1 or fewer heads. So it's the sum of getting 1 head and the sum of getting 0 heads. So the probability that I get less than or equal to 1 heads in 6 tosses of a coin, and that's going to be either getting 1 head or getting 0 heads in those 6 tosses. And so what I'm getting here in the second column, the column where I put in the word true for cumulative, is a running total. So this value here is the sum of these 3 values. This value in 0.65625 is the sum of 0 heads, 1 head, 2 head, 3 heads. So it's less than or equal to 3 heads. Once we've got this table, we can find a variety of probabilities. The probability of exactly 4 heads is, as we found before, the probability of 4 heads or fewer is going to be this value here, or alternatively, it is the sum 4 heads or fewer, so 0, 1, 2, 3, 4 heads. We get the same value. Less than 3 heads, we can either do this value here, less than 4 heads would be 3 or fewer. And again, alternatively, we can do the sum of 0, 1, 2, or 3 heads in those 6 tosses of the coin. Probability of at least 4 heads is going to be 4 or more. So a couple ways to do this. Maybe the more intuitive way is doing the sum. At least 4 heads would be 4, 5, or 6 heads. Another way to get at least 4 heads would be 1 subtract 3 or fewer heads. And last, probability of more than 4 heads would be 5 heads or 6 heads in our 6 tosses. And more than 4 heads could also be 1 subtract, let's see, more than 4, the complement of more than 4 would be 4 or less. And so again, most probabilities, there's a couple different ways you can go about solving it. All right, one more example. Here's a roulette wheel. Probability of landing on red 5 or more times. If we spin the roulette wheel 10 times. So our possible outcomes, 10 spins of roulette wheel. We could land on red as few as 0 times. It's going to be pretty unlikely, but possible. We could also land on red on the roulette wheel 1 time, and up through, it's possible to land on red all 10 times. So we're listing all possible outcomes of the experiment when we spin the roulette wheel 10 times and count the number of times we land on red. Our probability is a binomial probability, because either we land on red or we don't. And we're interested in the whole distribution here, so we'll start with probability landing on red 0 times in 10 spins. Our number of trials is 10. The probability of landing on red is the 18 red spaces on the roulette wheel out of the 38 spaces. And again, the first one here, we're going to use false. And then we can copy that down. Okay, and while we're at it, let's go ahead and do the cumulative table. So again, the cumulative table is going to give us a running sum. So we'll get the probabilities of less than or equal to 0 spins landing on red, 1 spin landing on red, 10 spins landing on red. 10 spins of the roulette wheel, probability on any one spin of landing on red, and then true. There we go. And that cumulative table should always end with 1. Let's see. So probability of landing on red in 5 or more spins of the wheel. Out of this value here, the 0.24270 is the probability of landing on red exactly 5 times out of the 10 times. And we want 5 or more. So that would be 5 or more would be landing on red 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. And so we've got a little bit better chance than 50% of landing on red 5 times or more.